Section 6 takes Section 5 one step further. All chapter long, we've been dealing with systems of equations. In the first section, we graphed systems of equations, 2 lines on the same grid. In Section 5, we graphed 1 line and had to shade because it was an inequality. That was the introduction to this section, which gets us back into systems of equations, but actually now they are systems of inequalities. A linear inequality means I got to talk about whether or not the line is solid or dotted, and I got to shade one way or the other. A system of linear inequalities means I'm going to have one linear inequality and then another one on the same grid, just like back in section 1, except now we're going to also shade. The nice thing is we don't have to worry about where these 2 lines cross, but we have to worry about the region that is shaded by both inequalities. So that's the big goal for this section. To solve a system of inequalities by graphing, put each inequality of the system in slope-intercept form. We've been doing that every time we graph anyway, so that's nothing new. Put both inequalities in slope-intercept form. Then, graph one inequality, just like we did in section 5, no big deal there. Determine which way to shade. So you're thinking about, is the line solid or dotted? And then which way do I shade, above the line or below the line? Mark it, but don't shade it just yet. I'll show you how to do that. Graph the remaining inequalities. Notice I said remaining inequalities. We might have not just 2 inequalities, we might have 3, 4, 5, there might be 10 inequalities. Not really in Algebra 1, but we will do a problem in this section where we have several inequalities all in the same graph. Then figure out the region. A region is like an area, right, in which every inequality shades. So different regions will get hit by different inequalities, but there's going to be one region, hopefully, that gets hit by all of the inequalities and shade it. That's the solution. Any intersections must be included on the graph. You don't have to tell me what the intersections are, but they have to be on the graph if they cross. So let me kind of give you a little example. Let's say I have one inequality, and when I graph it, I get a dotted line that looks like that, and then I'm supposed to shade it. So let me pick out a nice color here that's going to let me shade. Let's say I had to shade that thing above, so I shade it above. Then I graph another inequality, and this one gives me a solid line this time. Maybe it looks just like that. This inequality says that I have to shade some other direction. Like maybe I have to shade this one below. So I shade it below. Yeah, I was hoping it would. Notice that this inequality, this dotted line, shaded above. This inequality, the red line, the solid line, shaded below. And we had a region that was shaded by both. This one only got hit by one. This one didn't get hit by anything. This one only got hit by one. But this one got hit by both. That means that all of the ordered pairs in this region right here work for both inequalities at the same time. And that's why that is going to be our solution. So then that is what we would actually shade. This region. I don't know what's happening there. This region right here would be our final answer. So I'd really shade that in. Let me pick a color that actually looks nice. Really ugly color maybe. That didn't work. Well, you get the point. Black will probably do it. This is going to be our answer right here. That region. Okay? Now, we are not going to do all of this shading. And that's what I was trying to get at when I said, do not shade just yet. We're going to avoid all that shading because it just gets messy. I mean, take a look at what I did there. It was terrible, right? It's actually good that I did that. So we're going to avoid all of this mess and only shade the region that gets hit by everything in the end. And I'll show you how to do that. It's kind of a nice way to keep your homework assignments nice and clean. And it saves time too. So let's see. The usual rules for inequalities apply. We still need dotted lines or solid lines. And also watch out for negatives when you multiply or divide both sides of the inequality by a negative number, remember that you have to flip the inequality symbol, okay? Those pop up from time to time, and you have to be aware that they could pop up at any time. Here we go. Graph the system of inequalities. It's going to occur on the same grid. So for this first one, it's already in slope-intercept form. That's lovely. So how am I going to graph that thing? Start where? Yep, just slope-intercept form. So we start at -3, which is there. Put a dot. And then slope is 2, so we go up 2 from there. Right 1, up 2, right 1, up 2, right 1, all the way through. Reverse it, down 2, left 1, down 2, left 1, and now I'm out of space. Now remember that the rules for graphing, for me, are your line has to go all the way through the grid, and you got to put arrows at both ends. If you don't, I will take points away. This is the correct way to graph. Now, before I draw on that line, what kind of line am I going to draw? A dotted line, because this says less than right here. So I'm going to remember to draw a dotted line because I usually forget. I'm thinking dotted, dotted, there we go. Arrows at the ends, and that equation portion is done. But now we have to talk about which way to shade because it's an inequality. So what do I need to do to figure out where to shade? Pick a test point. Our test point is usually 0, 0, right here. So I plug 0, 0 in here, and I get 0 is less than -3. Is that true? No, that's false. So that means this test point did not work, which means this region does not work. Don't shade yet. Which means this region works. So I'm not going to shade. I'm going to mark it. I'm going to mark it by drawing little arrows down off of my line. That just tells me that that's the region that I'm shading. And it avoids having to shade all of that stuff. Okay? Little arrows down. They're not little arrows to the right. They're little arrows down. Always either up or down, above or below, never right and left, above or below. So now we need to go on to the second inequality. And how are we going to graph that one? First, slope-intercept form, that's right. So we're going to have to subtract 2x from both sides. And when we do, what do we get? Y is greater than -2x plus 2. Okay, that's slope-intercept form. So we're ready to graph this. Where do we start? Well, we got to put our dots on first, right? So we go up to 2, and then what? Yeah, that's a negative slope, -2, so we're going to go down 2, right 1 this time. Down 2, right 1, down 2, right 1, down 2, right 1. I'm out of room that way, so I reverse it, up 2, left 1, up 2, left 1. That gives me my negative slope line. Please make sure that you are checking the slope of your line compared to the slope of your inequality to make sure that at least it's going in the correct direction. Now, what kind of line are we going to draw here? Dotted line again. You do have to draw the line, whether it's solid or dotted. Just dots on the page aren't good enough. This one's going to be a dotted line, so I have to put that in there. Okay, now what? Test point. What's our test point? 0, 0 is fine. So if 0, 0 works, then we're going to be shading below. We'll draw little arrows down. If 0, 0 does not work, then we're going to be shading above our red line. Plug in 0 and 0, and I get 0 is greater than 2, which is false. So this test point did not work, which means I'll be shading above. So I draw little arrows up. Now that I've done that, I can see the region that's going to be double hit by my inequalities. This region right here did not get hit by anything, so it's not my solution. This region here only got hit by the red inequality. This region here only got hit by the blue inequality, but this one got hit by the blue and the red, and that's why this one is my solution. One more practice problem here. What do we do with that top one? Yeah, it's ready to graph. It's already slope-intercept form. So what do? Start 5, and then what? Down 1, right 1. That's a slope of -1. All the way through. Reverse directions. There we go. And what kind of line am I drawing here? Yeah, this one's going to be a solid line. It does matter. You do have to get that correct. All the way through the grid, solid line. Which way am I shading? That inequality symbol says greater than, and based on the shortcut, if we're in slope-intercept form, the shortcut says, if it says greater than, you're shading above. So I'm going to draw little arrows up from my line to tell me that I'm shading above. I'm not going to actually shade that region, though. Okay, how about that second inequality? What do I need to do? Put it in slope-intercept form. So how do I do that? Add 3x to both sides, which gives me good. So now that one's in slope-intercept form. So we graph it. Where do we start? -4, and then the slope is 3, so we're going to go up 3, right 1, up 3, right 1, up 3, right 1, and out of room there, so down 3, left 1, gets me one more dot, and now what? Yeah, this one's a solid line again. It's okay to have a solid line and a dotted line. It's just that this one was both solid. And which way are we shading this one? The inequality says less than, and less than, if I'm in slope-intercept form, says shade below. So I'm going to draw little arrows down. So in this case, what region got hit twice? Top right. So you're saying this one right here. Not this one? This one here. No? This one. Yeah, the blue line is hitting this region and this region. The red line is hitting this region and this region. This is the one that gets hit twice. So I shade here. That's the solution. Notice that my shading goes outside of these grid lines also. That's correct to do because these lines extend for forever, which means that this region also extends for forever. So it's okay to show that you understand that this actually goes out beyond just those grid lines. Writing a system of inequalities from a graph. This is going backwards. They give you the graph, and you have to come up with the system of inequalities. It's just a matter of learning how to do it, and then after that, a lot of people actually kind of think these are a little bit fun. So to do these, pick a line. Doesn't matter which one you pick first, just pick a line. And then see that it's either solid or dotted. And then see which way they're making it shade. If it's shading above, you're going to write this symbol greater than. If it's solid, then it's greater than or equal to. If it's dotted, then it's just greater than. If it's shading below and solid, then you're going to write less than or equal to. If it's shading below and dotted, then you're going to write just less than. Okay? So pick a line. Which one do you want to do? The red one or the blue one first? The red one. All right, the red line is dotted. Which way is it shading? Below. So for this inequality, the red one, let me change to red here. I'm going to write y is shading below, and it's dotted, so less than. Now all I got to do is figure out my y-intercept and my slope, and I have the inequality already written down. So what's the y-intercept here? 5. So I'm going to have plus 5. Now I just got to figure out my slope. So this is going down, which means it's going to be negative. Pick a couple of dots. We got one right here, and there's another one right there. So down 1, right 2. Down 1 means negative 1/2. There's your inequality right there. Now switch to the blue one. Blue line's solid. Which way are we shading? Above. So with a solid line shading above, I'm going to write y is what? Greater than or equal to. What's the slope of this line? The slope of this line is 1, x. Where do we start? Negative 1. So y is greater than or equal to x minus 1. There's your system of inequalities that generated that. I could easily give you a test question or a quiz question that look like this, and then it's multiple choice, or not, and you have to come up with the answer. Okay? It's a good problem to know how to do. So we have another one that's just like it down here. What system of inequalities is represented by the graph? Go ahead and give that one a shot. Start with one, just pick one, write it down, pick the other, figure it out. Which one do you want to do first? The blue one? Okay. So on this blue one, we're going to have y. And what inequality? Less than or equal to, because the blue one is a solid line, and it's not shading above for sure. It's shading below for sure. So that means less than or equal to. What's the slope? Positive 1/2 x. Where do we start? At 1. So plus 1. There's your inequality for the blue line. How about the red one? Y is, we're shading below, and it's dotted, so that makes it just less than. What's the slope of this one? Negative 1/2 x, and where are we starting? Positive 1. There you go. Oops, that's a plus. There's your system. Okay? So being able to take two inequalities and make a graph, or being able to write two inequalities from a graph, those are the two main things going on in this last section. The last problem for the chapter is a big story problem. Oh, it's not the big deal. When you are planning what to do after school. So you're putting some thought into it rather than just thinking, I need to go home and update my Clash of Clans castle. I can spend at most 6 hours a day playing basketball and doing homework by the time I get home. You want to spend less than 2 hours playing basketball. I don't know why, but apparently 2 hours is it. Can't take it anymore. You must spend at least an hour and a half on homework. That's like the rules. You have to spend an hour and a half on homework, at least. We need to make a graph showing how we can spend our time. So, in order to do this, and by the way, this is like an Algebra 2 problem. So if you can get this, then you're in pretty good shape for one of the chapters that we do in Algebra 2. When we do a story problem, what's the first thing we have to do? Define your variables. So we got to pick out the two things that are going on here. The two things that we can change are, I heard one of them, basketball and homework. We have hours or time, let's say time. Time doing what? Homework, okay. Time doing homework. And time doing, or playing, I guess, basketball. Two variables. Pick a couple letters. X and Y is fine. They're both times, so T doesn't really work there. H and B, you could do that if you wanted to, but there's no reason to make it any more complicated than it already is. X and Y is perfectly fine. Now that I know X and Y, on my graph that I have to make, can't have negative time for either, so bottom left is going to be perfectly fine for my origin and my axes. And then since I called homework X, homework goes there, and basketball on the y-axis. Now we need to use the information to come up with a system of inequalities. It doesn't have to be just 2. It can be more than 2. You are planning on what to do after school? Great. You can spend at most 6 hours daily playing basketball and doing homework. Can I spend more than 6 hours? No. I have to spend less than 6 hours. Can I spend exactly 6 hours? Yes. So actually less than or equal to 6 hours. How do I get to 6 hours? X plus Y. Assuming that all I do when I go home is either play basketball or do homework, then I have X plus Y is less than or equal to 6. There's one inequality right there. Okay, that takes care of that line right there. Now, you want to spend less than 2 hours playing basketball. I want to spend less than 2 hours playing basketball. Well, basketball is my Y variable. So that means Y has to be less than or equal to 2. Okay, see if we're done. It says you must spend, Mom says you got to spend at least an hour and a half on homework. X is greater than or equal to 1 1/2. So we actually came up with 3 inequalities for this situation. What is a graph showing how you can spend your time? We can do that. That's no big deal. X plus Y is less than or equal to 6. How could I graph that? You could subtract X from both sides, put it in slope-intercept form. If I do that, what do I get? Negative X plus 6. Remember, we subtracted X from both sides. Also, I could graph this one just using intercepts. My X-intercept, if I cover up the Y, is 6. My Y-intercept, if I cover up the X, is 6. It becomes very easy to graph if I just use intercepts. This one is going to be what kind of line? It's solid for sure, but this one's horizontal, and this one is vertical. And notice that this one's going to be going through 2, and this one's going to be going through 1 1/2. With my intercepts here, I have to have at least 6 here and at least 6 here. I have 14 lines. Graphing using intercepts actually helps me come up with the scale here. 14 lines, and I got to make it to 6. A good scale here is to go by 1/2. By 1/2. Okay, so I can graph this inequality using the original inequality here, or I can use slope-intercept form like I found here. Either one is fine. If I use the slope-intercept form, when I go up 1, 2, 3, 4, 5, 6, right there, because I'm going by halves. This is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Now for this one, my slope is -1. So I go down 1, which is to there, right 1, which is to there. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. What kind of a line do I draw here? Solid. Actually, all of these lines are going to be solid. We don't have any that are just less than or just greater than. Now, because I was in slope-intercept form down here, and that inequality says less than, which way am I shading? Below. So I'm going to draw little arrows below to remind me that I'm shading that way. The next one that we have is this y is less than or equal to 2. How do I draw that one? 2 on the which axis? On the y-axis. And that's a horizontal line. And that one is also solid, like we said. So there's my line. And which way am I shading this one? It says less than or equal to, so that means shade below. So it's helpful to stop. Since we have one more to go, where would I be shading if I was done right now? This shape right here. Yeah, this trapezoid right here. Okay? So as of right now, I'm shading this region, but I still have this one here to put in there. Once I put that one in there and figure out which way to shade, then I'll have my answer. So, how do I graph x is greater than or equal to 1.5? X-axis 1.5 is right there, and that's a vertical line, and that one's solid, just like the others in this case. Now, which way do we shade? It says greater than or equal to. There's no above or below here. So, greater than numbers. Numbers that are greater than 1.5 are like 2, 3, 4. That's numbers that are this way. So we're going to shade this way. The only time you can say right or left is with a vertical line. Otherwise, it's up or down, above or below, always. So what is our resulting region then? This trapezoid right here. So we'd shade here. What is a graph showing how you can spend your time? This is a graph showing how you can spend your time. Any amount of homework and basketball within this region right here works for mom, makes her happy. All right? So this is something you could do at home to show your mom that you're doing your best to make her happy. And then you'd be using math and actually learning the math, and then mom would be even happier. You get like 2 gold stars for the day. So that does it for the section and the chapter. Actually, I want to go back. I forgot one thing. On this last problem right here, part B, is the point where the boundary lines intersect a solution of the system. So they're talking about this point right here. On this particular problem, is that point a solution? What do you think? Yes or no? Okay, the answer is no. Does somebody know why? If they were both solid lines, then yes, this point right here would be a solution. But because of this dotted line right here, this dotted line, remember, represents that we can't actually have ordered pairs that are directly on that line. This one you can, but this one you can't. And because this dot right here falls on a dotted line, then we can't actually have that particular ordered pair in our solution. So the answer to this would be no, because of the fact that we have this dotted line sitting right here. So just something to be aware of there. It's kind of an important thing. Now officially that is it for the chapter.